Good morning, all of you. Yesterday we were discussing a end-to-end log file that is collected on MME. So far we have studied just 4 steps. So we have to complete a lot. What we have seen so far. Mobile equipment have sent a EMM attach request and PDN connectivity request message, NAS message to eNode B as part of RRC connection setup complete. And that message arrived at MME um, with initial in a S1 AP message called as initial UE message. It arrived at MME by including S1 AP UE ID. eNode has sent it to MME. So what is MME doing now? MME has requested HSS to send the authentication information to challenge the mobile and as well as to use the keys for security mechanisms. So for those purposes, MME, MME needs the MME needs the uh, security details. So it is requesting those security details from HSS. So it is the duty of HSS to provide that information. So we have studied that HSS has indeed sent that information to MME. That was the last step we have studied in our yesterday's session. So if you look into this, diameter inbound message, there is authentication information answer, and only proxy flag is set to 1, request flag is not set to 1, and it is a F6A message. The reply coming back with these AVPs. You have the first AVP, the session ID, that is exactly the session ID used by MME. It is just a copy paste done by the HSS. And HSS is sending a vendor specific application ID. That means HSS is notifying that I belong to a vendor ID called 10415, represents 3GPP, and I am operating on authentication application ID 1677251, represents S6A. So these details are, of course, we know it as at a human level. So it is machine level, the informations are being sent. Result code. What happened to the diameter procedure initiated by MME? Diameter success. And authentication session state in LTE, it is always going to be no state maintained, always. So no chance of having any other value. That is what is decided at the starting. So we have the origin host. This is the HSS name. We have HSS diameter name and origin rem. HSS belongs to which domain? The HSS domain and MME domain are basically same because they are part of same single network in this case. That means the mobile user is not roaming. Mobile user is in a home network. So that is what this represents. The domain name same. And then we have supported features. As I have explained you yesterday, supported features is a grouped AVP containing many more AVPs inside. And the first AVP that is present inside is vendor ID. Vendor ID value is 10,415. HSS announcing that I belong to 3GPP organization and I am containing exactly one list of features and that list of features are these. So this basically is a 32-bit value, this feature list. This 32-bit value, if you convert it into binary, it will get converted into a binary number with ones and zeros. So one bit will represent one feature. So if the bit is set to 1, the feature is enabled, and if the bit is set to 0, the feature is disabled. So this is how this works out. So that is the purpose of feature list. we have. And the most crucial details that MME is requesting for. What is it? The actual authentication information. What is the authentication information? It is sending one UTRA vector. HSS is sending one UTRA vector to UTRA vector to MME. Only one. Why? Because at the time of requesting, MME might have requested only one, so you are sending only one. So that's the primary reason for that. And in that UTRA vector, we have an item number, which is just like a sequence number. It could be any number, simply a unique number, that's all. And then the important details, random number. The random number that is originated by your authentication center. XRES, the one that is calculated for the purpose of validating the user. Then we have authentication token, which is calculated by using something called a sequence number and PLM and ID. So authentication token. And then we have KASME, the key that is calculated, which is going to be useful for MME, eNodeB, etc., for enabling the security mechanisms like integrity protection and ciphering to enable various activities. We use this KASME. All right. So we have all these fields. Great. So what next? We have once the authentication details arrive at the MME, now MME wanted to challenge the mobile, to see whether he is genuine guy or not. Okay, so how he does that? It prepares one NAS message first. It is preparing outbound NAS message. What is the NAS message? It is EPS mobility management message, EMM message, and the message is EMM message, and it is a plain message. It is not yet encrypted or integrity protected, and the message type value is hexadecimal value 52, which represents authentication request. So MME is MME is preparing authentication request message. Then we have one key set identifier or KSI, and then we have the KSI, key set identifier, and key set index. We have the value is this 6 key set index value. So now with this key set index value 6, the most important details that MME is sending to mobile equipment is this random number and authentication token. With the help of these two parameters, now it is the duty of the mobile equipment to calculate the XRES and prove his genuinity. But we cannot send the NAS message directly to the mobile. There is no way. What do we have to do is always the NAS messages must be packed into S1AP message to send it, because we are studying the log on MME. So what happens now? Immediately this NAS would be packed into an S1AP message called downlink NAS transport, and it is a downlink NAS transport containing 3 information elements. First information element is MME UE S1 API ID. So MME has created one S1 API UE ID for the mobile. Okay, great. What else we have after this MME UE S1 API ID? The number is this. This is the unique number from now onwards, which will be used for recognizing the mobile on MME. So MME might be dealing with lakhs of users. For each user, one MME US1 API ID would be there. This is the ID for this particular mobile. And then the second one is eNodeB UES1 API ID. This is a unique number that eNodeB has created earlier and sent it to you. You are just sending it back. So in every S1AP message from now onwards, we will have these two IDs present in every S1AP message, whether it is going from eNodeB to MME or MME to eNodeB. I'm not going to explain these two IDs every time again and again and again. When we see it 100 times, all the 100 times I won't explain because that will become repetitive. You will be bored, and that is not meaning of the technology. That is the meaning of maybe like step level spoon feeding. So you have to automatically understand that from now onwards in every message we have these two IDs. I just mention it maybe once, but I will just ignore them from now onwards. But it would be there. All these two IEs will be there in every single message. And the third information element is the NAS PDU that MME is preparing. That is the EPS mobility management message. So this is the actual NAS message, which is a big hexadecimal string. But if you try to understand what that hexadecimal string containing, that hexadecimal string is containing this following information. It is a EPS mobility management message, and it is a plain message. It is not a secured or encrypted, not integrity protected, or neither secure ciphered. Authentication request, and the key set index value is 6. Native means it is not derived. Derived means if the mobile is coming from SGSN to MME, that time by taking the SGSN operating keys, if MME derives the keys, that is called as a derived security context. But when we have used native, meaning is the MME gathered the security information from your security information from the component itself, from HSS itself, and random number and authentication token. Like, okay, what is the difference between this NAS message we have seen and earlier NAS message we have seen? No difference. The earlier NAS message is the one actually prepared by your prepared by your MME. But MME is packing that NAS message into S1AP. In one of the information elements, it is packing the NAS PDU and sending it to eNodeB. So MME packs this authentication request into a downlink NAS transport S1AP message, send it to eNodeB. What does eNodeB do? Which we can't see it in the log. eNodeB sends this NAS message to UE. It sends it to UE, this authentication request NAS message, in a RRC message called as downlink information transfer. So it will extract from S1AP, pack it into RRC, and eNodeB would be sending it to UE, the RRC message to UE, like one IE. This NAS message becomes IE inside RRC right now. And once it is sent to UE, UE gets authentication request, he gets the challenge, he gets the random number, he gets the authentication token. So what does the UE do after getting these two details? What is that UE is going to do? UE would be replying back uplink information transfer. It is replying back with uplink information transfer, NAS authentication response. It is replying back to eNodeB as. And these two messages we won't be able to see in the log because the log is collected on MME. We will be able to see only MME based interactions. Now what happens finally? Once eNodeB receives this authentication response message in uplink information transfer, it converts it into, it packs it into, it extracts the NAS and packs it into S1AP message, uplink NAS transport, and send it to MME. This authentication response would be again packed into S1AP message. Which message? Uplink NAS transport. It would pack it into. Okay, so we now see the other one. Okay, so we see this here. So we have inbound. Over here we have the inbound. uplink NAS transport. So the message that is arriving is S1AP message, and it is uplink NAS transport message. How many IEs are there, and how many information elements are there inside? First information elements are MMEU ES1AP ID, this fixed number, eNodeBU ES1AP ID, and this number. These two IDs are to recognize the user both on eNodeB side as well as MME side. I have explained in the previous message that these two IEs will be there in every single message between MME and eNodeB from now onwards. And the purpose of eNodeB to send this message is to carry a message called as a NAS PDU. This NAS PDU is containing it is a EPS mobility management message, and it is a plain NAS message, and it is the message that we have received is having a hexadecimal value 53, which represents the authentication response. So mobile equipment has sent a authentication response message to eNodeB. eNodeB is packing and sending it to MME, and this is the actual response. This response is nothing but our XRES. This is the XRES that is coming in from the mobile. Now, what MME have to do is it need to match this XRES with the XRES received from HSS. It needs to match that. That's the point. But information elements are not finished. Two more information elements we have. What are those? U-Trust Cell ID. Mobile equipment is right now present in this PLM and identity 214365, nothing but 123456, and cell identity is this 0007B00. So we are sending mobile equipment's present cell ID, mobile equipment's present tracking area ID. So mobile's present tracking area ID is 92A, and PLM ID is 214365, and tracking area code is 92A. We are sending these details. Okay, now what is the point? Why the cell ID and tracking area ID would be sent? If you remember, I have explained you one important concept. At the time when the mobile equipment is initiating a procedure called as tracking area update, mobile equipment have to send only information about in which old from which old tracking area it is coming. Mobile equipment never need to report what is its present tracking area ID in the NAS message. So mobile sends a NAS message called as a tracking area update to eNodeB, while eNodeB sending that tracking area update message to MME. eNodeB itself have to include the cell ID and the tracking area ID that the mobile belongs to. That details need to be included. Okay, so what is the point? What I'm trying to convey here. So eNodeB will never be able to recognize which NAS message is a tracking area update NAS message or which NAS messages are other NAS messages. eNodeB will never be able to understand that logic. So they have decided that because eNodeB cannot read the NAS messages to find out which one is a tracking area update NAS message, they have standardized a mechanism where every single time that eNodeB sends a NAS message to MME, eNodeB may think that okay, this may be a tracking area update message. So what do I have to do is I have to attach the cell ID and tracking area ID and send it to MME so that MME can understand mobile's present tracking area details, mobile's present cell related information. For that purpose, I have to make this happen. So that is the basic point here. So we are making eNodeB send this tracking area and cell ID details every single time a NAS message comes in. So remember, every time eNodeB sends a NAS message to MME, totally there would be 5 information elements. What are the 5 information elements? 2 information elements are the IDs itself, the eNodeB S1 APU EID, MME S1 API ID. and one information element is the actual NAS message. Uh, because this NAS message could be tracking area update, which node doesn't know it whether it is a tracking area update or not. But irrespective of it, 3GPP decided to keep this information. Another two information elements are going to be containing your tracking area ID and your cell ID, CGI, ECGI, or a world cell global identity. Yeah, it will contain these details. So totally 5 information elements would be present whenever node B sends any NAS message to MME. Okay, so the message arrived. Once the message arrived, what does MME do? MME will validate this response that we have received with the response received from HSS. Once the response is validated, um, you are going to response is validated, you are going to proceed further. MME is going to proceed further. What is the next step for MME to proceed further? MME have to activate something called as security mode. NAS level security must be activated. So MME triggers a Okay, we have received this NAS message. NAS message always will be shown 2 times while sending time or receiving time. It will be shown 1 time as part of S1AP message, 1 time separately. So this is the authentication response we have received. So what MME is doing, it is preparing an outbound NAS message called uh, EPS mobility management message once again, right? But this time it is an integrity protected NAS message. This time it is not a plain NAS message. So your plain NAS message is packed inside integrity protected mechanism. So that is why it is including NAS count value as 0, and it is calculating something called as a MAC, the original MAC, a message authentication code for integrity protection, to validate the integrity of this message. So at the time of enabling the security itself, we are enabling the integrity protection. So this is integrity protected. Okay. So, and the actual EPS mobility management message that we are sending, the plain message which is packed in this integrity mechanism, is it is actually a plain message which is security mode command, and asking the mobile equipment to activate the NAS level security by using this integrity algorithm, by using this ciphering algorithm, and providing the KSI ASME, the key set index. Key set index value is it is native key set index value is 6. Already the key set index value 6 related the random number and authentication token already sent to the mobile. Mobile would have already calculated the keys needed. So we are just sending the key set number to explain the mobile equipment by using which key set we are going to perform security mechanism from now onwards using this key set number 6. Spare half anyway will be 0. Replayed UE security capability is UE security capability information which is replayed back to UE itself. MME has learned it. MME is sending it back to the UE for reconfirmation. So that's it. That is the information that. So original message that will be prepared by NAS is this. But after preparing this plain message, what does MME do is he will then convert this NAS message into security protected, into integrity protected NAS message, and it will be adding the MAC and NAS count value. It is including. Okay. So once it is notified to the mobile equipment as security protected, integrity protected, and ciphered, mobile understands that okay. I think MME has sent me a message by enabling the security on his side. To understand it, I have to calculate the keys on my own. So with the help of the random number and authentication token and key value, mobile fatafat calculate all the keys needed. CKIK, from that it will generate KSME, from that it will generate NAS integrity key, NAS encryption key, and he will try to decrypt this NAS message arrived, the non-access signaling NAS message arrived. And once the mobile decrypts it, mobile understands that, okay, indeed, the MME has sent a NAS message called as security mode command, asking the mobile equipment to enable the security. Now mobile have to explain his opinion whether he is accepting this or rejecting this security mode activation. But this is the NAS message. We can never send the NAS message from MME to mobile equipment directly. What do we need to do? We have to pack this NAS message into S1AP. Again, when we are packing into S1AP, there will exactly be three IEs present, three information elements present. What are those three IEs? Two IEs are IDs. Enode S1APU EID and MME S1APU EID. And the one information element is going to be this NAS message itself. So totally it will be having three IEs. In the downlink time, we will have three IEs. Uplink will have five IEs, including mobile is present under which tracking area, which is cell. So if you look into that S1AP message, downlink NAS transport containing three information elements, MME UES1 APID, Enode BS UES1 APID, and followed by the NAS PDO, the one that we have prepared. So this is the NAS message. Okay. So once this NAS message is sent to Enode B, what does Enode B do? So MME is sending a downlink NAS transport to Enode B. Security mode command NAS message, packing it into S1AP. Enode B forwards this to UE, which we cannot see in the log file, but it goes on RRC, downlink information transfer, security mode command. RRC extracts this NAS message and forward it to NAS protocol. The NAS protocol prepares a reply, whether he is accepting the security mode or rejecting it. It replies back with the uplink information transfer, RRC message. Inside that NAS message would be present security mode complete. So mobile accepting the security mode activation, and it is explaining to Enode B that yes, I am accepting the activation. Thank you. All right. So once this is accepted and reply sent to Enode B. Enode B's duty is simple. It is only doing the relay of the NAS messages right now, and it has to extract this NAS message, pack it into pack it into another S1AP message and send it to MME. The S1AP message is uplink NAS transport, the S1AP message. Okay. So in this uplink NAS transport message, we have security mode complete that is received by MME. So the NAS message again, this S1AP message will contain five IEs, two user IDs, and one NAS message itself, and the fourth one and fifth one are tracking area ID and cell ID of the mobile. So five IEs will be included and sent to MME. So what does MME do? So now we are going to see the reverse message. Inbound S1AP, the one that is coming from the mobile, uplink NAS transport, it is sending. And in this uplink NAS transport, as usual, we have five IDs. No need to study, simply read them. MME UES1 APID, Enode B UES1 APID, followed by the NAS PDO. One strange thing happened to NAS PDO right now is NAS PDO is right now, it is security protected and integrity protected. It security enabled, integrity protected. This is the NAS message, but it is security protected and ciphered NAS message. It is both integrity protected as well as ciphered. So for that integrity protection, mobile equipment has included the MAC, and the NAS count value, uplink count value is 0. It has included those values, but it is definitely integrity protected and ciphered. Now, why this information is not getting displayed here? Why not? The reason is pretty simple. S1AP can never decode NAS messages. Earlier, NAS messages were not ciphered. We could able to read the NAS messages earlier. From now onwards, we cannot read the NAS messages which are going to be present in your S1AP messages, because they are in secured state and protected mechanism, or integrity protected mechanism. So we will only be able to read the NAS message from now onwards only once it is extracted from the S1AP message. So we have two more information elements: UTRA CGA ID, tracking area ID. We will have these two details: UTRA cell ID and tracking area ID. Okay, once we have these two details, what we'll have? We'll have inbound. So what is inbound? We have here inbound. The NAS message is now decoded by the received MME. What is this? NAS message is decoded here. So it was originally security and integrity protected with this MAC, but once it is deciphered, you will have a plain message present inside it. The plain NAS message is security mode complete without having any further details, meaning is mobile is accepting the security mode activation for the NAS messages. Indeed, it has ciphered the NAS message we have received as well. So it not only activated the security mode, it has now it has done the security for that. It has ciphered that security of that NAS message. So the plain NAS message you took, he has converted into a integrity protected and ciphered NAS message, and that NAS message has been received with MAC for validating the MAC I and the NAS count value. Okay. Now at this stage, what MME is doing? MME is preparing an outbound message called update location request. So MME decided to go to talk to HSS and gather the subscription information from the HSS, subscriber details from HSS. Sorry. So what is this update location request? It is a way of communicating to HSS and tell the HSS that mobile successfully completed his security mechanisms, and I now want the mobile subscription information from you so that I can proceed further with the step. What about IMEI validation? IMEI validation is there, but it will be dependent on MME's configuration. If operators MMEs are not configured to verify the IMEI number, they won't verify. But if MMEs are verified, then MME takes the responsibility of sending the S1AP message called downlink NAS transport with identity request present inside, and once this identity request is sent to UE on RRC protocol message, UE replies back with identity response. Once this identity response comes to MME, so MME has received the IMEI number. Now we need to validate whether the IMEI number is genuine or not. We need to go to talk to EAR with the ME identity check request, and EAR sends back ME identity check response explaining him that the mobile is a genuine guy, IMEI number is in whitelist. It reports back, and then MME proceeds further to HSS to do the update location request and to receive the update location answer and receive the information it requires called the subscriber information. Directly we are studying this step. So what happened to this step from here to here? What happened to all this part? Now this is if on MME, if the IMEI validation is disabled by the operator, um, you know, if it is disabled, so MME won't do it. MME won't need to validate IMEI number is genuine or not. So these steps will be excluded, and these two steps also would be excluded, communicating with the AR. So MME directly have to send update location request to HSS if this is disabled. So we are seeing a MME where the IME validation has been disabled. That is why it is performing directly the update location request bypassing those steps. Okay, what details? This is a diameter protocol message, and the diameter version 1, the protocol message length is 348 bytes. It's operator's choice when the validation is mandatory. Again, for example, in India, mostly operators don't care about IMEI validations. That is why even the stolen mobile phones would be used. If your mobile phone is stolen and if you give a complaint, it must be blocked everywhere. So if operators are properly implementing the norms that are surrounding your IMEI numbers, so the stolen mobile phones will have no chance to be used anywhere. But typically the people who steal the mobile phones, that is an industry in itself. They will steal it in one state, and they know that even if the person gives the complaint, that IMEI number will be distributed as a stolen number to only that particular state's operators. Only in that particular state's operators, the IMEI number will be put into blacklist. Even if the MMEs are validating the IMEI number, only the operators which are present in that particular circle will be validating the number and finding out that this is a blacklisted mobile and reject the registration or reject the procedures. But if the mobile is taken to other circles, these IMEI numbers are not. This information is not available for other circles, as you are not maintaining a unified database to save the costs. All the operators would do it. So obviously, what happens when such a number goes to the other state, it can be identified as a whitelisted mobile, and it can be used for your procedures. So it all depends on how government is in Indian case it is a TRI regulations. Um, TRI will regulate, TRI will say that it will need to be done, but how far operators do it and how far TRI takes it seriously, it all depends on implementation. So it's implementation choice. So operators, to save their own costs and everything, they don't care most of the time. They don't care who is using the mobile. If they are using their SIM card, they are getting the money. They don't care why we have to be very accurate here. If we be accurate, the person who has stolen your mobile phone stop using your SIM card. Meaning is you will be getting less money. Why you have to bother about it if the government is not bothering and individual citizens are not bothering? So it's all goes down to the regulations and implementations. It's not technical. So, but MME behaves on the basis of configuration. If MME is configured to verify, it verifies as per its duty. You got that? Because yeah. So outbound. Um, so request flag is set and proxy flag is set. That is why the value is 192. First two bits are set to 1, remaining all the bits are zeros. So anyway, last 4 bits are reserved. These 2 bits are E, error, and T, potentially retransmitted. So if the T flag is set to 0, it is the first time transmitted diameter message. If E flag is set to 0, this diameter message is not containing any errors. So only proxy flag is set to 1 and request flag is set to 1. We have only 2 flags that are set to 1. Fine. It's a 3GPP A6A message, and there is some hop by hop ID, there is some end-to-end ID, which we don't bother, just numbers. And the session ID, so MME created a new session ID for the mobile because we know that the session ID will be exclusively terminated every time. We already knew that logic from our earlier subject learning. We understood that. So 002 dam proxy mme.starn.com, we have session ID. Then we have authentication session state, no state maintained, authentication session status. And origin host, this is MME's ID, diameter ID. Origin rem, it is starn.com. Destination host, this is the destination host ID. That is nothing but HSS ID. How MME knew the HSS ID? Because MME already interacted with HSS once. That time HSS quoted the destination ID. So you're including the destination ID this time. Earlier you did not quote the destination ID in the previous diameter message authentication information request. We have only quoted destination rem. But this time, because MME already learned about MME's ID, HSS ID, it is including HSS ID. And destination rem, this is the domain. Of course, your origin rem and destination rem are same. That means both the components are present in the same operator network, connected through a TRA in the middle. And the username is the IMSI number that MME is sending. Because we are not maintaining the same session ID again and again, every single time you have to code the IMSI number in the form of an username. That is why we are sending the IMSI number. 123456 is the mobile country code, mobile network code, and the 7890123445 is the MSIN, mobile subscriber identification number. And then MME, as usual, quoting is supported features. Every single time we would be quoting the supported features. Vendor ID, feature list, number of features it is sending is one. Feature list is this number. This number is going to be converted into binary. Depending on the binary bits are set to ones or zeros, corresponding features are considered to be activated or not. But if you look into these AVPs, every single AVP is containing vendor ID field present. So vendor ID is set to 10,415, representing that this AVP is a 3GPP specific AVP. This 10,415 represents that. Every single time we are including that vendor ID. Okay. Radio access technology type. Even this AVP also is 3GPP specific AVP. So 10,415 vendor ID included. It is length is 16 bytes. 12 bytes is the header. 4 bytes is the actual message, which is UTRA. So it is conveying that mobile equipment is connected to UTRA. So when the number 1004 is sent, it represents UTRA. Maybe 10,003 represents UTRA. It is like that. Different numbers represent different things. So mobile is successfully connected to which radio access technology? UTRA radio technology. And there are some ULR flags. Every single diameter message will have its own flags. So the flags would be sent as a separate AVP on its own. We did not study these flag level information related to the messages. We have ignored it because not so important technology wise. So we have ignored that part. And visited PLMN ID. Mobile equipment is connected to which PLMN right now? That 1, 2, 3, 4, 5, 6 PLMN ID. So MME is not conveying any new information to HSS. The whole and sole purpose of sending this message called as update location request is to explain MME that you please note down that the mobile equipment is going to be with me from now onwards, and also you have to send his subscriber details. I want to know the subscriber details of the user. Please send me those details. I need it. Okay. So inbound update location answer. So HSS is responding back positively. Update location answer. Only proxy flag is set. Request flag is not set. It is a 3GPP 6 specific message, and session ID, the same session ID that is sent by the MME, it's copy pasted as it is, and HSS is reporting back vendor specific application ID followed by result code. What happened? Diameter success. It is reporting the result code as that, and that means HSS has noted down that mobile is with this MME now, and HSS is also reporting you the details that you have requested, which is subscriber information. The primary duty of HSS in its reply message is send subscriber details. So authentication session state, as usual, is no state maintained. As usual, we have this origin state, host, origin rem, etc. You don't need to send destination host to destination rem in the answer messages, because answer messages always travel with the help of some number called as hop by hop ID. So that is why in answer messages we will never have. Inbound is incoming, Jagdish. Outbound is outgoing. That is the first thing I have explained yesterday. You might have missed it. Inbound means MME is receiving it. Outbound means MME is sending it out. So this is now sent by HSS coming to MME because we are capturing the log on MME. Okay, so we have origin host and origin rem included here. These details have been added. Then we have supported features. The supported features, again, as usual, same information, vendor ID, feature list ID, number of feature lists, and feature list itself will contain. Then the actual AVP starts. So the actual AVP is subscription information. Subscription data is the actual thing that is requested by the MME from HSS. Now HSS is going to send all the subscriber details that it is storing in its database. That's the primary duty of HSS. How does HSS know the subscriber data? Operator have stored it. How operator knew? Because mobile requested from some subscription services. So operator knew. That is the primary idea. Okay, so subscription data. So subscriber status. Subscriber status is set to operator determined barring. That means this guy, if required, operator can bar this guy. It is explaining, but right now it is not barred, but he is prone to operator barring. And the MSISDN, mobile subscriber ISDN number. Is there any MSISDN available for the mobile? Yes, available. This is the number. This is the number we give it to our friends actually. The MSISDN number. Great. Next, network access mode. Mobile is subscribed for what kind of services? Only packet-based services. He is not subscribed for circuit switched services, and we should not allow the mobile equipment to make CS calls, circuit switched calls. No, we should not. That is the meaning of this network access mode set to only packet. Operator determined barring. 0, meaning is operator has not barred this user right now, but mobile is vulnerable for operator barring, but at this stage no barring happened. 3GPP charging characteristics. There is a charging rule that is applicable for the mobile, which is told in the HSS 1234. This is not the final rule. This is only the information stored in HSS. Then which one will be the final rule, charging rule that will be applicable for the mobile? The final charging rule that would be applicable for the mobile is the one that is enabled by your PCRF. So this rule when MME learns about this rule, MME sends this rule to S gateway, P gateway, and P gateway mentions about this rule to PCRF. PCRF may accept this rule, or PCRF may change this rule. So that rule related details will be considered as data. So what is it? That is none of our business. It just you are understand it as a number. So that will be internally identified by these billing components. What is the meaning of this rule? 1, 2, 3, 4. Aggregate maximum bit rate that is applicable for the mobile. AMBR. So AMBR is a grouped AVP containing maximum requested bandwidth uplink. There is some value 10,000. Maximum requested bandwidth downlink, which is some 20,000. This is the total data rate that is applicable for the mobile aggregate maximum bit rate. So these two AVPs are present inside grouped AVP. How do we know that this is a grouped AVP? If we see these things here, if we see these things starting from here, we know that they are grouped AVPs. So in position of the data, we have the AVPs. That means this AVP's data is getting converted into some other AVPs. It is like that. Such a thing is what we call as grouped AVPs. What next? APN configuration profile. So what is the mobile equipment's APN configuration? HSS is sending it to MME by including something called as context identifier, context ID. Context ID is set to 1, and it is saying all APN configuration included indicator. It's saying all APN configurations included. That means HSS is sending all the access point names that mobile has subscribed for, and mobile is allowed to be connected to. It is sending all the details to MME. So this is the actual APN configuration that is deriving from HSS. This itself is a big, grouped AVP. This APN configuration itself, what details would be present inside? This APN configuration itself contains a context identifier, ID 1. With 11 context identifier, it will contain 11 APN related details. So first, it contains PDN type, IPv4, IPv6 PDN mobile can be connected to, and the name of that PDN is starn.com. Normally names won't be like this because this is a test environment. The name is like starn.com. In a real environment, name will be like internet, name would be like IMS, name would be like VPN1, VPN2, like that. So names of the networks. The most popular network that we have in the world is internet. So service selection will contain the PDN name. It is it is set to starn.com PDN. For this particular starn.com service selection, what is the EPS subscribed quality of service profile? Again, this is a grouped AVP, EPS subscribed quality of service profile. It is containing. So what is the quality of service class identifier applicable for that PDN for the default bearer QCI9? Allocation retention priority, your ARP value containing priority level as 1. Preemption capability is preemption capability enabled, and preemption vulnerability enabled as well. So from here to here, this is package is subscribed quality of service profile for the mobile for this particular starn.com PDN. And then we have one more information present here. VP element dynamic address allowed or not? It is allowed. VP element dynamic address. So what is this PLM and dynamic address? Is dynamic IP address allocation is allowed or not allowed? That is that. Next, then there is this information called as MIPv6 agent info. What is this MIPv6 and related details? I will explain them later because I haven't even explained you what is the meaning of MIPv6. It stands for mobile IPv6. Why do we need it and all that we'll understand in advanced LTE concepts. So after that only I will be able to explain this grouped AVP from here to here. Sorry. So the grouped AVP from here to here. So we can ignore it. And the last parameter that is present at this same level is PDN, not last parameter, three more parameters we have. PDN gateway allocation type, dynamic. So this mobile equipment is not having any static PDN gateway. So HSS is not providing the PDN gateway that is going to help mobile connect to this particular PDN. So it is not providing anything. So HSS is explaining MME, you are having the responsibility to find out which PDN gateway can help the mobile and which S gateway can connect to that PDN gateway. Finding that will be your duty, because I'm not providing you any PDN gateway information about which PDN gateway is going to help the mobile to connect to this particular packet data network. It is not providing it. And individual charging characteristics that are applicable for each PDN. For this particular PDN, charging rule that is applicable is 1, 2, 3, 4, which is equal to global rule. The global rule is 1, 2, 3, 4. This particular PDN specific 3GPP charging characteristic rule is 1, 2, 3, 4. And for every PDN, we have a AMBR, aggregate maximum bit rate, for every PDN. So the global ANBR is one thing. It is individual PDN's maximum bitrate and for uplink and maximum bitrate for downlink. So this ANBR is a grouped AVP again. Maximum requested uplink bandwidth uplink. We have 10,000 kbps in uplink and 20,000 kbps in downlink. So we have set that to ANBR. This is applicable for this PDN. With that, this PDN specific information is completed. One APN configuration is completed specific to one particular PDN. Now starts next. Another APN configuration. For this, the context ID will be 2. Okay, so that means the total subscriber information is getting divided.
Sir, I have a question here. As you explained, there is some charging rule with respective to PDN, right? So whenever this information is downloaded from HSS, so every charging rule which belongs to that specific to subscriber profile is downloaded. Like every rule, for
basically,
yeah.
Every information that is stored in HSS, a copy of it will be sent to MME. Okay, including all these details. A copy of it will be always maintained at MME. That's the point. But whether MME uses directly them or not is a different choice, different concept. For example, charging rule, if MME gets it, MME is not going to do the billing. Then what does MME use the charging rule for? MME sends it to S gateway to P gateway at the time of enabling a bearer. P gateway verify that rule against your PCRF. PCRF is the ultimate decider whether you would like to continue using that rule or you want to suggest a new rule. If PCRF wanted to suggest a new rule, PCRF suggests a new rule indeed.
So in that case, HSS is already updated if something is changed. So
HSS doesn't care, and the information need not to go back to HSS. Not required. HSS is a static database. Its duty is to provide all the information it is having to MME. That's all. That is only his duty. Nothing else it does.
Fine, sir. Thank you.
So all the PDN configuration that we have is divided into contexts. How many contexts will be divided into? How many APN configurations that HSS want to send to MME? MME would be receiving that many context IDs. What is the requirement for dividing the whole data into contexts? If, for example, suddenly, if the mobile equipment is decredited from connecting to a PDN packet data network, then HSS will send delete subscriber data with the corresponding context identifier, explaining MME that, hey man, you can delete the configuration specific to this context ID too, because mobile did not subscribe to connect to that PDN anymore. You don't want to pay that money. You don't want to pay that money. So he told me to not keep that service. So I'm telling you to delete this particular context ID related information. So this entire packaged information will be sent. So for every APN configuration, the details will be similar. It will contain a PDN name, as IPv4, IPv6 service selection. This time the name of the PDN network is abc.com. Simply they have added dummy names because this is a test. These log files are collected on a test environment, and EPS subscribed quality of service profile containing what is the default bearer's QCA value. Again, allocation retention priority, preemption vulnerability is preemption capability is enabled, preemption vulnerability is enabled. These kind of details, and VP element dynamic address allowed, and MIPv6 agent information you have. And then we have what is the PDN gateway allocation type, dynamic, and the charging characteristics. Again, rule is 1, 2, 3, 4 for even for this PDN also. And what is the aggregate maximum bit rate applicable for this particular PDN? 10,000 and 20,000. So it is going to be that. And now again, what starts? Now another APN configuration starts. One more APN configuration. This time, PDN type is IPv4, IPv6. Service selection is xyz.com. Details will be similarly configured. Now, if you understand it, this is at this particular level. Right now, we are here. So this level, the next entry we have at that level is this one. Okay, so up to from here to here, it is one APN configuration with context ID 3. So if I shift till there, if I go here, I would see one more APN configuration. So with context ID 4, the information is getting repeated. So that's the primary idea. So we have this here. Again, the next one is this APN configuration 5 we have here. Okay, with service selection, PDN name as starrentv6.com. Again, the next one is this APN configuration, context ID 6. Service selection is apn4.com. So mobile has subscribed for a lot of PDNs, and all these are different PDNs. APN configuration, context ID 7, and service selection is apn5.com. And then again we have APN configuration, context ID 8, service selection is apn6.com. APN configuration, context identifier 9, a context identifier 10, context identifier 11, context identifier 12, context identifier 13. Okay, that's the end of it. I know that there is another message here. So this is the last APN configuration that we have. So this also will contain details. Name of the PDN is apn11.com, and the quality of service class identifier applicable for this PDN is QCA9, and allocation retention priority is priority 1, preemption capability enabled, vulnerability also enabled. And then we have VP element dynamic address allowed is allowed, and MIPv6 we are skipping, then followed by PDN gateway that is going to help you to connect to this PDN should be dynamically selected by MME, and 3GPP charging characteristics are 1, 2, 3, 4, and we have aim BR value, maximum bit rate, and maximum bit rate for both uplink and downlink. So with that, the packaged information is completed. So the service information is done. With this is the last piece of information we have received. So from this, what can we understand is MME is explaining HSS is explaining MME that mobile equipment is totally subscribed to connected to 13 PDNs because there are 13 context identifiers are present, and for each PDN in this dummy example, almost all the parameters are equal. Same quality of service parameters were used, and the same everything same was used in here. But in reality, it should not be the case. In reality, it should be working in a different way, obviously. So, what is the meaning of different way here? What is the meaning of it? For every PDN, there is a possibility of different quality of service and different data rates in the real world. So that's my point. And there is one other advanced LTE parameter called as RAT frequency selection priority, which is set to 2. Basically, the meaning is it wanted to select the U-turn as the radio frequency thing. Basically, that is his prioritized network. So this is also some kind of a subscriber information itself, coming arriving from HSS to MMA. Okay. Now we are at what stage? We are at update location answer received. So MME gathered all the subscriber details for the mobile. So what MME is going to do now in the next step? MME will have to start creating the required control plane tunnels and user plane tunnels towards S gateway and P gateway by sending this create session request. But before we send this create session request, there is a trouble. What is the trouble? MME, for none of the PDNs, MME never received any information called which P gateway services MME should use. That information never came to us. So, what MME is supposed to do now here? MME need to find out a combination of S gateway and P gateway who can help mobile equipment connected to this P gateway. MME need to find out because HSS did not provide that information. So what MME is performing right now? MME is sending an outbound message called DNS outbound message. So because this DNS is a voice-side protocol, you must have learned that DNS protocol already in voice-side classes. So I have not included this in our actual protocol learning list. So MME uses a generic IP networking protocol called as a DNS to find out information about which P gateway can help us connect to a particular PDN. So what is the question MME is asking this DNS server by generating an outbound DNS message and sending it to DNS server which is present on this particular IP address operating on DNS registered port 53. What is it? It is sending, asking a request that, hey, I want to connect to a starn.com PDN and its APN I want to connect to, which belongs to Evolved Packet System, Evolved Packet Core network. I want to connect to the P gateway that is present in MNC 456, mobile network code 456 under mobile country code 123, 3GPPnetwork.org. So right now, my mobile, I want to connect to a PDN which is present under 3GPP network, which is present under mobile country code, this mobile network code, and belongs to EPC. Can you please suggest me such a P gateway which is present under this subnetwork, which helps me to connect to a APN of this PDN, starn.com PDN. So it is explained that full question in here. So indirectly we are asking for P gateways details, the P gateway that is helping you to connect to the PDN packet data network. Now all the for example, mobile subscribed for 13 PDNs. Now all the 13 PDNs cannot be supported by a single P gateway. Need not be. Their operator can have 4 P gateways. One P gateway is supporting 4 PDNs, another one 4, another one 4, maybe the another last PDN is supporting 3. So are supporting 1 PDN. Totally we have 13 PDNs. supported by 4 different P gateways. It could be that. So we are finding out for this PDN, for this PDN's APN, we have to go through which P gateway, and that P gateway must be present under this network. We are not asking for a P gateway which is present anywhere. No, we are asking that should be present in this location. Okay, now we are getting a inbound DNS reply. So in the DNS reply, what information would be present? A lot of details would be present. I'm not explaining you the DNS related information here. We are just reading the part. So we have received answer for this question that you have asked, and it is telling us that I am getting you a P gateway information. The name of the P gateway is this pgateway.node1.3gppnetwork.org, and this P gateway's details are, this P gateway's IP address is known to me. So this P gateway's IP address is 192.168.40.1. If you can contact this guy with this IP address, he can help you to connect to this particular PDN that you would like to connect to. So MME got a reply from the DNS. So what happens now? Once he gets the reply, he's getting additional details also, like 3GPP networks, name, server, IP address, etc. But we can ignore them. We can ignore that extra parts. We are interested. We are only studying the interested part here. So what's happening next? Now MME is already found out P gateway. Now he would like to find out to connect to that P gateway, which S gateway will be perfect. You want to find out. So he's sending another DNS message to the DNS server. Yes, man, I would like to now talk to the P gateway, but I can never directly talk to P gateway because I'm a MME. I have to go through an S gateway, obviously. So I need an S gateway who can help me connect to this P gateway. So that is what you are requesting. So first it will provide one information. It will provide the name server's information only. It is not providing directly the S gateways information. It is just providing name server information at the starting. With that name server, you are then providing your details, like mobile equipment belongs to which tracking area code, and belongs to which EPC network, etc. And you are telling that the S gateway that can support, we are sending one more DNS query that the S gateway that must be present in this network and must be connected to the enode base under this tracking area ID and tracking area code. So this is actually tracking area ID, not tracking area code, but it is a combination of details. It belongs to these two tracking areas we are listing. So once we provide these information, so what does DNS need to do? DNS need to search in his database, find out a S gateway which can be connected to the enode base present under working with these tracking areas. So present under this EPC network. So DNS need now come back with a reply, and so inbound you got a reply for this query, and such a S gateway who can help you out is sgateway.node1.3gpp network.org. That is the name of the S gateway, and other primary information is this. For this name of the S gateway, the IP address associated with is this 192.30.30.10. We found out. Okay, so what is the interesting part that I have explained you now as part of this log analysis? Now, just now I have told you earlier, I have never mentioned anywhere in our previous classes. This is the first time I have told you. That is, MME always will find S gateway and P gateway dynamically when HSS doesn't provide the P gateways information. If HSS provides the P gateways information from the stored details to MME need to find out only a corresponding S gateway who can help you to connect to that P gateway, and that too the S gateway present in so and so technology network. So you can find out those details from the DNS server by questioning the DNS, but it is dynamically selected. If HSS is not providing any information, MME is not blindly going to the same S gateway, P gateway every time, depending on which PDN mobile equipment would like to connect to. That PDN is connected to which P gateway, and that we can reach that P gateway from which S gateway, and that S gateway also should be, in a state connected to be our eNode P. The tracking areas belongs to our eNode Ps. Such a S gateway we need to pick, and then MME will trigger the create session request towards this particular S gateway right now. So this create session request goes to that S gateway that it has picked up. Okay, so the message outbound, it is a S11 GTPC message, GTP header, GTP version 2. Piggybacking flag is not present, meaning is we have not stacked the GTPC messages one top of the other. We are sending a single GTPC message. TEID that is there is present. T flag is set to 1. TEID is present, and the message is create session request. So this is the message that is going out, create session request. And message length is 226 bytes, including all the information elements. TEID is 0. Why TEID is 0? We already learned this concept. When MME is proposing this thing for the first time, it will always use the TEID 0 because MME doesn't know the TEID that is going to be created by S gateway once the proposal is sent. To represent that this is a new guy, MME always use the TEID 0 here. And there is a sequence number for the GTPC message, just a sequence number. And now starts the information elements, not AVPs, information elements. In GTP, we have information elements because GTP is a protocol defined by 3GPP. IMSI number, 123456, PLMN ID and the number, and the MSISDN. MSISDN number is procured by HSS, procured by MME from HSS as part of the previous message. MME received this. And user location details. Not only MME keeps the user location and maintains the user location information himself, but he will have to provide this user location details to S gateway and P gateway for the purpose of dealing with the non-3GPP handover scenarios. We study them as part of advanced LTE sessions, but they are required there. So user location info. So mobile is present in which tracking area ID. Mobile is present in mobile country code 123, mobile network code 456, tracking area ID is 92A. Mobile is present under which cell 123456 PLMN. The cell ID is 7B00. Up to 7B it is the eNode B ID, 00 is the cell ID. So MME is forwarding user location information to S gateway. Furthermore, mobile equipment is present in which serving network, nothing but the PLMN ID separately, 123456, that is the PLMN ID. Radio access technology, mobile is connected to UTRA. So MME is conveying that to S gateway. And the MME control FTEID. MME is including the TEID that it is creating for this particular user. It has to create the TEIDs. So that is the TEID we have. So MME S11 control plane tunnel ID. So tunnel ID information always will always be two things. One is whether the tunnel is working on IPv4 technology or IPv6. IPv4 flag is set to 1. Represent we are having IPv4 address. So this is the MME's IP address at 10.30.30.2, and this is the TEID that MME is creating for this user. From this time onwards, next time onwards, if any time S gateway wanted to send a reply, any S gateway wanted to send a message to MME related to this particular user, this TEID must be quoted in the header because MME created this TEID as a reference to this particular user. So MME is providing this TEID information to S gateway. MME is using TEAD 0 in its header, because MME doesn't know what is the TEAD that is going to be created by S gateway in the future. That is why it is using 0. But if you see, 192.30.32 is the MME's IP address. 192.30.30.10 is the S gateway's IP address. Indeed, this is the S gateway's IP address we have learned from the DNS server. So we are pointing the we are sending our GTP message to this particular IP address, meaning is to this particular S gateway we are sending it to. Which message? GTPC message we are sending with what TEAD? 0, because you don't know the S gateway's TEAD yet. That's why you are using 0. But MME is including its TEAD. MME TEAD. MME is operating IP address. It is confirming once again that my IP address is 10.30.32 on which you have to reach me, and this is my tunnel ID on which you have to reach me. And then P gateway control FTEAD. It is sending. How does MME know the P gateway's TEAD? Actually, MME doesn't know the P gateway's tunnel ID. It is a bluff. In a way of sending the P gateway tunnel ID, the actual intention of MME is to send P gateway's IP address to the S gateway as 192.168.60.1. Why? Because S gateway can reach many P gateways. It is a in LTE we have something called the flat architecture. Node base can connect to any number of S gateways. S gateway can be connected to any number of P gateways. So S gateway don't know the mobile equipment is connecting to which, or to connect to this particular PDN, which P gateway services we have to use. Again, S gateway don't want to consult DNS because MME has already done the job. So what MME is doing, you know, as if it is sending a TEAD, it is mentioning about the P gateway's IP address details to S gateway. Now, if you look into the TEAD that is used by the P gateway is 0 here. It is using as 0 TEAD. Great. So we have that. And then what we have? Access point name to which network the mobile would like to connect to. The PDM that belongs to, that is named as starn.com. So this is the access point name of that particular PDN. Selection mode. It is MS or network provided APN. It is subscriber verified, but it is mobile provided or network provided. In our case, it is network provided because mobile have never sent any APN details in its NAS message. It is this information is been arrived from HSS. MME learned it from HSS. So that is called as network provided. If MME, a mobile station or UE itself is providing the APN details, then it will be called as MS provided APN. PDN type. Mobile would like to connect to PDN in IPv4 technology mode, not in IPv6. Meaning is it is indirectly demanding an IPv4 address. So PDN address allocation, right now the mobile equipment's IP address is 0.0.0.0, representing mobile doesn't have IP address. When MME sends such information to S gateway forwards it to P gateway fills the IP address in this 0000 position. Then we have some indication flags. We are just ignoring all these flags at this particular stage. Most of them are related to advanced LTE sessions. We'll include one or two things we can understand. Authenticated MC. Mobile is already completed the authentication. Piggybacking feature is supported for this user. Yes, one bit represents one feature basically. 1 means it is enabled, 0 means it is disabled. Protocol type 0 means it is GTP version 2. Maybe 1 means it is GTP version 1. Like that, one flag will contain one information. Basically, it is that. Next. Are there any APN restrictions that are applicable for the mobile? No, 0. What is the aggregate maximum bitrate information MME gathered from the HSS? 10 kbps to 20 kbps uplink and downlink that is applicable for this particular mobile. And the protocol configuration options, we have ignored this protocol configuration options until we study IMS, IP multimedia subsystem, and advanced LTE concepts. We cannot understand it. So we are ignoring this protocol configuration options part for time being. And the last package that is present is bearer context to be created. How many bearers are being requested by MME to be created? EPS bearer ID 5. It is basically a default bearer. Bearer quality of service is the least QCI 9 with no guaranteed bitrate in uplink or no guaranteed bitrate in downlink. It is a non-GBR bearer with very basic QCI, the least amount of QCI that is available. We are creating a bearer, EPS bearer ID 5. MME is ordering, so MME is ordering S gateway to create a default EPS bearer related things. And recovery, we have how many times the MME has been restarted so far? 189 times. He has restarted. Its present recovery value is 189. UE time zone, mobile equipment comes into which time zone? So plus 5:30 DST, mobile is right now in that time zone. Charging characteristics that we have learned from HSS. MME learned this charging rule from HSS. MME is sending it to S gateway. Of course, S gateway would send it to P gateway. P gateway have to verify it with PCRF. So our procedure proceeds further. MME sent this message to S gateway. S gateway communicates with P gateway. This message we can't see in the log because we can see the messages that MME either receives or sends. None of the other messages we cannot see. So this message we can't see, but it happens by creating the tunnels. The message goes to P gateway. P gateway sends a CC request message to PCRF. That message also we can't see in this log file. It replies back with CC answer, provides you the PCC rules. And in the CC request, the billing rule mentioned by MME will be sent to PCRF. PCRF may keep that billing rule or may change the billing rule. He may keep the data rate that is suggested, that is subscribed by the mobile, or he may change the data rate also. So in the CC answer, all those details will be present. And when P gateway sends create session response message back to S gateway, S gateway sends create session response message back to MME. Now, we cannot see all these 4 messages. We won't be able to see that. Directly, we will be seeing this response message from S gateway arriving at MME. So, we go back. So, if you see the message inbound, it is incoming to the MME GTP message from 30:30:10 to 30:32. It is arriving, and message name is create session request message. We have create session response. TEID is this. What is this TEID used by S gateway while replying back? We go back. So when I have clicked on this, this one highlights that part. You see there is a highlighted part here. So this highlighted part is basically telling us that is the MME quoted TEID. So whatever the TEID MME quoted in the form of an IE in the previous message, your S gateway is using that message in the header, that TEID in the header. So with that, MME recognizes this particular create session response is for this user to whom I have created this TEID. So every component works the same way. From now onwards, we should never use this 0. Every time we should be using a proper TEID. So what details are present inside this? What information elements are present? eGTP cause request accepted, meaning is the procedure has been accepted. Both control plane parts are done, and also your S gateway is reporting a bearer context is also successfully created. Both control plane part is successful. This represents control plane part. This represents related to the bearer, the user plane part. The user plane part is successfully done. So which EPS bearer has been created successfully on S gateway and P gateway? S gateway to P gateway, S5S8 bearer got created. S gateway opened a bearer towards E node B as well for EPS bearer number 5. So bearer creation has been accepted, and the charging ID is 12121212. So charging ID is not the same now. Charging ID has been changed. Who changed it? Definitely we know who changed it. It is the PCRF who have changed it. Definitely no other choice. It is the PCRF who has done it. And then S gateway data FTE we have so S gateway S1U 192.60.60.13 we have S gateways S1U interface 192.60.60.13 is the S1U interface, meaning is towards E node B. S gateway created this IP address and this tunnel ID to receive the uplink traffic. These are uplink traffic tunneling details. And then the P gateway tunnel ID details are also sent for user plane. P gateway's IP address, P gateway's tunnel ID. Why P gateway's IP address and tunnel ID are needed for MME? These P gateway's details need not be sent to E node B. MME keeps it in his database. Why? Suddenly, if mobile equipment is doing a handover, moving into new E node B, as part of the handover procedure, if S gateway changes, for example, that time MME will provide this P gateway tunnel details to the new S gateway. It will forward it to the new S gateway that is coming into the operation. Why S gateway is changing? Because we are changing the E node B. Not the new E node B is not connected to the old S gateway, so we tend to change S gateways in that situation. When MME found out that the old S gateway is not serving the new tracking area mobile is moving into, we need to use the services of a new S gateway. He find out a new S gateway and it forwards the P gateway details, P gateway tunnel details to that new S gateway at the time of the handover. So for that reason, MME need to store P gateway's user plane tunnel details as well as the control plane tunnel details for the event of S gateway's change. But as long as that S gateway change is not happening, MME will have to simply store this information without any use, without any immediate use. Then the recovery parameter, how many times the S gateway has restarted so far, 101 times. And the control plane tunnel IDs finally, S gateway control tunnel ID and S gateway's TEID is 4D3. The from next time onwards, MME is going to talk to S gateway. MME must use this tunnel ID 4D3. It must use and S gateway's IP address is 192.30.30.10. This is the S11 interface TEID. That the MME must use to communicate with the S gateway. MME should not use tunnel ID 0 next time. He must use this tunnel ID. Okay, great. Next, APN restriction. So the APN restriction, no nothing, and P gateway's TEID as well. So P gateway's TEID on S5S8 interface and P gateway's IP address. It is P gateway can have multiple IP addresses. His global IP address will be different. His private IP addresses will be different. He can quote different IP addresses for different purposes. It is all in play. It need not be a single IP address. So P gateway's IP address. So again, MME need to store this P gateway's control plane tunnel ID details for the event of S gateway's change. If S gateway is not changing, there is no need for this. And then we have protocol configuration options, which we have ignored. We learned that as part of advanced LTE. We are ignoring it. Okay, so great. So once this response comes back, MME understands that this right-hand side part is completed. Now MME starts preparing the left-hand side part. MME triggers a initial UE context setup request to eNode B with presenting a NAS message called as EMM attach accept plus default EPS bearer context activation request. It sends that message to eNode B. So the thing we are preparing outbound NAS message, it is a EPS mobility management message, EMM message, and it is attach accept and containing some timer value. Fine, there is some spare half and timer value. Mobile is connecting to only EPS network, not connecting to CS plus PS, only PS. Tracking area ID list. How many tracking areas mobile equipment should not do tracking area update? The adjacent tracking areas. These are the adjacent tracking areas in which mobile should not be doing the tracking area update. Uh, 2346, 2347, 2348, 2356, 2357, 2358. And then not only EPS EMM message is present, there is a ESM message as well, ESM container, EPS session management. And in this EPS session management, we have message type, activate default bearer request for EPS bearer ID 5 and quality of service class identifier is 9, connecting to a PDN APN called as starent.com, and the IP address that is allocated to mobile equipment is 12.0.0.1. Actually, this IP address is learned by the mobile in the earlier message. In the create session response, the detail will be sent to the mobile here. 12.0.0.1. This is the IP address that is allocated to the mobile by the P gateway. Now we are sending that IP address information by tagging it into NAS message. We are sending it to the mobile phone. MME is sending it to the mobile. And these negotiated quality of service parameters are required for 3G mechanism. That means if mobile equipment goes into 3G network suddenly, mobile needs the quality of service parameters, 3G parameters. In 3G, there are a lot of quality of service parameter. They have simplified that mechanism in LTE. We have very few quality of service parameters in LTE, but for the eventuality of making the mobile equipment ready to go into 3G or 2G network, we have to convert the quality of service information into 3G, 2G parameters and provide it to the mobile. So all these details are 3G specific parameters that are applicable for the mobile. Again, mobile's NAS layer will simply store it. It is useless until and unless mobile goes into 3G network. It simply stores it into the NAS layer and keeps it. Only in the event of mobile going into the 3G network, these details would be useful. Otherwise, no use. And mobile's maximum bitrate applicable is 10 kbps and 20 kbps. There is no guaranteed bitrate for the default bearer that is getting created right now, because it is a default bearer. No guaranteed bitrate would be applicable for it. And it is a best effort traffic, and aggregate maximum bitrate is 20 kbps and 10 kbps. There are protocol configuration options which we have ignored. And the last parameter we have is EPS mobile identity, which is basically part of your EMM message itself. It is part of EMM message called as GUTI, Global Unique Temporary Identifier, PLMN ID, mobile country code, mobile network code, followed by MME group ID. This is the group MME belongs to MME code. This is a MME individual code, and what is the MTC that is getting allocated by MME. So totally, how many details have arrived here are 5 details: mobile country code, network code, MME group ID, MME ID, followed by MTC. Together we call it as global unique temporary identifier. So mobile has got allocated a global unique temporary identifier. And there is another timer value, T3423. For some purposes we use the timers. It is set to some timer value. And there is one more parameter, network supported features. It is not listed anyway. Nothing is listed there. So this whole thing is a NAS message. But if you understand, anytime we send a NAS message, we always have to pack the NAS message inside the S1 EP message. So what does MME do? MME packs that NAS message into a S1 EP message called as initial context setup, initiating message, initial context setup it prepares. In this, it is going to include MME UES1 API ID. It includes enode BU S1 API ID. The two IDs as usual will be there every time, and aggregate maximum bit rate that is applicable for the mobile 20,000 bits per second, 10,000 bits per second, 10 kbps and 20 kbps. We are sending these details to enode B because enode B need to know the quality of service as well, because enode B also need to deal with the QoS mechanisms. So MME is sending this information to enode B. You can argue, hey, these details are already present in the NAS message. Why are you sending it again? Because enode B cannot understand the NAS message. Enode B can only read S1 AP message. So we are packing these details in the form of S1 AP message. And MME is ordering enode B to, with the fourth IE, MME is ordering enode B to create ERAP, a new ERAP to be set up. So what is the ERAP we are setting up? So ERAP to be set up item we are sending, and ERAP ID is 5. We are sending ERAP ID 5. Okay, and ERAP level quality of service parameters, QCA 9. So we not only have to give the quality of service details to mobile equipment in the form of NAS message, we need to provide the same details to enode B as well. So QCA 9 and allocation retention priority may trigger preemption, and preemptible preemption is enabled, and this guy also can trigger the preemption. So that priority level is 1 we have set, and the transport layer address is the IP address. So this thing is the IP address of S gateway. So MME is sending S gateway IP address details to enode B. So if you take hexadecimal values, C0, it is equal to 192. So this is 192.3C. It refers to 3C. 3C is decimal value is 60. So 3C is 60, 192.60.60.0D. So you are having 0D, which is 13. So 192.60.60.13 is the IP address of S gateway. So we are providing S gateways S1U IP address and S gateways tunnel ID details, which we have received from the S gateway to enode B. That is the duty of MME. MME need to share the S gateway tunnel details to enode B tunnel details to S gateway. He has that responsibility. And we have the NAS PDU we have here, the NAS message, NAS security and integrity protected NAS message. Which is this NAS message? This NAS message is the one that we have prepared, which is EMM attach accept plus default bearer activation request. By including it, MME is ordering enode B to create the ERAB. Along with this, additionally, MME also will send information to enode B, UE security capability information. What is the encryption algorithms the mobile equipment can support? What is the integrity algorithms mobile equipment can support, including the security key. This is the K enode B that is sent by MME to enode B, K enode B, which is sending in the form of an IE. With the help of this key, mobile equipment have to, enode B have to derive 3 keys, RRC integrity key, RRC encryption key, and as well as user plane encryption key. Mobile will use this key to generate, enode B will use this key to generate 3 keys to enable the PDCP level security mechanism. And then there is some advanced LTE part we ignore. Subscriber profile ID for RFP. So radio frequency priority, we just ignore that for time being. What happens now? Enode B first enables the security mode command. How? By using this K enode B, it calculates the required keys that are arrived in this message. By using that keys, it suggests the UE that let us enable the security mode at PDCP level. I want to create the DRPs. For doing that, I need security must be enabled. So once requested, UE comes back and says I'm accepting the PDCP level security activation. Mobile also calculates the keys on his own. eNodeB won't send the key. eNodeB only send algorithm information to UE. Once the security is activated, then eNodeB sends RRC connection reconfiguration request to UE, asking him to create a DRB, data radio bearer, that is going to be part of our EPS bearer. Along with this RRC reconfiguration request requesting for DRB, we whatever the NAS message that is arrived, the same NAS message we pack it into this RRC connection reconfiguration, send it to mobile. Mobile's RRC will read the RRC part, extract the NAS message and send it to NAS layer. RRC will do two jobs. So what does the mobile equipment's RRC will do? Mobile equipment's RRC first will send RRC connection reconfiguration complete to eNodeB, reporting that I have done the reconfiguration, I have created the DRB successfully on my side. It reports the success. Once the successful report comes back from the UE, immediately eNodeB sends a message to MME called initial UE context setup response. It is sending it to MME. What is this initial UE context setup response? It is reporting to MME, hey, you have asked me to do a job. You have asked me to enable the security. I have done that. You have asked me to create a ERAB. I have done that. ERAB is nothing but radio bearer plus S1 bearer. Radio bearer I have created towards the UE. S1 bearer also I have created towards S gateway. In this message, the details will be included. What details? So we first see this initial UE context setup response message. So the next message that is arriving inbound, initial context setup successful outcome, that is arriving from the eNodeB. How many information elements? 3. MME UEID, eNodeB UEID, followed by how many ERABs that are successful, ERAB setup list as part of the context. So in this ERAB setup item, how many are set up successfully? ERAB ID is 5, and then the transport layer address is the IP address of eNodeB. eNodeB's IP address is C080A, which represents again C0 value is 192. 0A is a 10, 0E is a 10, 0E is a 10, 192.10.10.10. That is the IP address of eNodeB. So eNodeB is telling my IP address is 192.10.10.10 and my tunnel ID is this GTP tunnel ID, which you need to forward it to S gateway. So we have sent it. So once this message is sent to MME, MME is supposed to forward these tunnel details to S gateway. It is supposed to forward, but it needs to wait for the permission from the UE. UE has to accept the activation of the default bearer. So what does UE do? UE will send a NAS message by packing it into RRC message called as uplink information transfer. It sends to eNodeB EMM attach complete and ESM message default bearer activation acceptance. Once this NAS message arrives at eNodeB, eNodeB extracts it, forwards this to MME in a message called as uplink NAS transport. So MME need to wait for this uplink NAS transport message for the activation of the default bearer. So this RRC connection and initial UE context setup simply told MME that the ERAB has got created. All the pieces are got created, but still mobile need to activate it, need to accept to activate it. So this is the creation success. This is the acceptance for activating it. So the next message we see is another inbound message from the node B called as S1AP message, uplink NAS transport. So what is this message containing? So totally 5 information elements, MME UES1 APID, enode UES1 APID, and the NAS message which is in encrypted format, which need to be decrypted. It will be decrypted at the NAS level, cannot be decrypted at S1AP level. But we can see that the NAS message is present here. And the other 2 information elements are cell ID and tracking area ID. These 2 things are always be there. So now, once we decrypt the NAS message, we decode the NAS message and understand, the MME understands that this inbound NAS message is EPS mobility management message, which is attached complete. So EMM message is attached complete. And there is a ESM message present as well, EPS session management message, and mobile is accepting is EPS bearer ID 5 is accepting to activate that default bearer. He has sent the acceptance to MME. So once the acceptance is sent to MME, what MME is supposed to do? MME need to convey the information to S gateway. Tell him that, hey, you already have created the S1U tunnels as part of this create session response message. You have done it. Thank you. I have already provided those details to enode B as part of this message. Just now I have received the tunnel details from enode B, and I'm making sure I have made sure that the mobile accepting the activation. Now I am sending you the tunnel details in this modify bearer request message to you. So so the next message that goes out is an outbound S11 message on which protocol, GTP protocol, sent from MME to S gateway, and it is modified bearer request with the TEID, this TEID. This TEID is the TEID quoted by S gateway. MME is not using the TEID 0 anymore. It is using this 4D3 TEID created by S gateway as part of create session response. And bearer context to be modified for EPS bearer ID 5. MME is bringing enode B FTEID details for S1U interface. It is bringing, this is the TEID created by enode B. This is the IP address created by enode B. 192.10.10.10 is the IP address of enode B. And if you want to send the traffic to mobile, this particular mobile, you have to use this TEID in the GTPU header. So we are sending these details to S gateway. Who is sending it? MME is sending it to S gateway. These details. Great. So what is MME doing? Sorry, what is S gateway doing? It is sending a reply that is coming to MME in the form of inbound modify bearer response. S gateway is using the tunnel ID created by MME 8001-2007. In the previous message also it has used it, and it said that cause request accepted. So your control plane part, it is accepted, and it is accepting the user plane specific activity also. eGTP cause request accepted for the bearer related functionality as well. What is accepted for this bearer ID 5? S gateway has noted down the tunnel ID details, and it is reconfirming his tunnel ID details once again. For S gateway S1U interface, his tunnel ID is this. His IP address is 192.60.60.13. It is reconfirming it. The details are already known to MME. So it is just reconfirming as part of the acceptance. So that's it. And there are some closed subscriber group mechanisms which we ignore for time being. Which S gateway is sending it to MME. Is mobile equipment subscribed to any closed subscriber groups or not, like private enode Bs? If subscribed, to which closed subscriber groups mobile subscribed to? So CSG ID. So this is the closed subscriber group mobile belongs to private cells, private inode base. So that details are kept here. Fine, leave that part for time being. And there are some indication flags which we are ignoring, and this is also related to CSG, which we are ignoring right now. So once this reply comes back from S gateway to MME, so one last step will be there here. So the last step is MME will have to notify to HSS because a major event occurred. So what is the major event occurred right now? A major event that is occurred is mobile equipment successfully connected to a service. Is connected to a PDM successfully by creating a default bearer needed, radio bearer between UE to eNode be created, a S1 tunnel between eNode B to S gateway got created, S gateway to P gateway S5 S8 tunnel got created, and the um, mobile equipment accepted the activation of the default bearer and MME has activated it. So by using that bearer, mobile equipment can now successfully communicate with the corresponding PDN packet data network. So now MME is supposed to explain this situation to HSS with a notify request and HSS will simply respond back with a notify answer. So the last message we are going to have is an outbound diameter message, which is sent to HSS notify request. Code is 323. Request flag is set to 1. Proxy flag is set to 1. 3GPP S6A message this is. And new session ID will be created for this transaction. Authentication session state, no state maintained. Origin host is MME's name. Origin rem is MME's domain. Destination host is HSS name. Destination rem is HSS domain. For which user we are sending this information is this user which belongs to mobile country code, mobile network code, and your subscriber number. And supported features is always present, the same thing. And there is some MIPv6 related information which we are ignoring for time being. We study this as part of advanced LTE sessions. And the most important thing here is the service selection and the notify request to which PDN mobile equipment connected to. So to a torrent.com PDN mobile equipment has been connected to. We have reported this to HSS. So HSS will simply send a reply without containing any technical details. So it responds back with inbound message. What details would be there? He simply sends notify answer and he says that that's it. Thank you, man. Result code. I'm accepting diameter. Accept. I have noted down the information you have sent. None of the details are important. It are all repeating details themselves. Supporting features, origin host, origin rem, authentication session state. Result code is only reporting the situation, diameter success. Your application ID, which is that session ID. So all are repeating details only. There is no information present in this notify answer. The main purpose of notify answer is to report diameter success. That's it. Now at this stage, we can say right now, at this situation right now, we can say that the mobile equipment is connected to the LTE network, that too successfully connected to the LTE network and completed the attach procedure perfectly. Now, two more steps are there. I don't want to leave this part to the remaining class into the next part because it will be creating unnecessary break. Even though we are delayed a bit, we will complete in the next 10 minutes. This Sunday anyway. Inbound uplink NAS transport. So there is a NAS message arriving from the mobile. eNode B is packing it into uplink NAS transport and sending it to MME. It is containing, as usual, 5 information elements. What are those? Right now, mobile is in attached state. Maybe mobile might be transporting the data as well or transported the data on the EPL default bearer. But suddenly, this uplink NAS message is arriving. 5 IEs, 2 IEs are MME UEID, eNode B UEID. Third one is the encrypted NAS PDU, which need to be decrypted, and mobile equipment's present cell and the mobile equipment's present tracking area code. All these details have been quoted. Once we decrypt the NAS message, we understand the NAS message as It is a EMM message, EPS mobility management message, and that is a detach request. We are asking for EPS detach by quoting your present key set index 6 and by quoting your GUTI number 123456, MME group ID and MME code and MTMC. Why mobile equipment is detaching? We don't know. Maybe mobile user has switched off the mobile and at the time of switching off, mobile is proposing MME that I want to detach from the LTE network. So mobile has got freedom to detach. So it is sending the detach request. It is pure EMM message, EPS mobility management message. Okay, so what happens now? First, outbound, we are sending a GTPC message called as delete session request, asking the S gateway to destroy everything that is created for the mobile equipment. So we are telling that for this mobile, everything need to be destroyed, including EPS bearer ID 5. The control tunnel ID for this guy is this. I'm quoting the control tunnel ID I'm using for this user. Everything need to be deleted for this guy. So it is the proposal delete session request means that. So once this proposal is sent with the delete session request by quoting this TEID, yes, gateway understands this delete session is applicable for which mobile, for the mobile whom this TEID is present. And S gateway communicates with P gateway. It asks P gateway to delete everything. P gateway responds back successfully. Once S gateway receives the response back from P gateway successfully, P gateway replies back with P gateway responds to S gateway. S gateway replies back to MME. Delete session response inbound by using this tunnel ID, and the cause request is accepted. And of course, recovery value is the same, but the cause request is accepted. Meaning is it has deleted everything. All the control plane tunnels, all the user plane tunnels are deleted on S gateway, P gateway, everywhere. It is destroyed. So because mobile equipment has proposed for a detach, MME is communicating with S gateway, P gateway, deleting everything that it is there. Because these bearers are already deleted, we know that mobile equipment is no more having a service and no more connected to a PDN called as starent.com PDN. No more. We are not connected to this PDN anymore. So what does MME need to do is it needs to notify the situation to HSS, explaining a notify request to HSS that mobile equipment is detaching from a service called as starent.com. So this notify request we are sending once again, not to report HSS that mobile equipment is connecting to a new service. It is to report that mobile equipment is disconnecting from the service by sending this notify request once again. How MME concluded that the mobile detached? Because already the corresponding S5, S1 bearer has been delinked, S5, S8 bearer has been delinked. There is no way mobile can send IP packets to PDN or mobile can receive IP packets from PDN. Once this is done, we are yet to receive the reply. Reply may arrive a little late, but meanwhile, MME is preparing a NAS message to send to the mobile called as EMM message, detach accept. So it is explaining the mobile equipment that, hey, thank you very much for asking me for detaching. I'm doing that exact same thing that you have requested. I'm detaching. I'm accepting your detach request proposal. So this is a NAS message. We always pack the NAS messages and send it in the form of S1 AP. So pack this NAS in S1 AP with the 3 IEs present inside. One IE will be MME UE S1 AP ID, eNode B UE S1 AP ID, and the NAS PDU which is encrypted. Of course, eNode B don't know that this is all going on. The mobile equipment is detaching. eNode B doesn't know because eNode B can't read the NAS messages. It is none of his business. He simply unpacks this NAS message and send it towards the mobile equipment by using RRC procedure. Once mobile gets it, mobile's RRC gets it, RRC sends it to NAS. UE's NAS understands that, okay, detach is accepted. Now I have to shut down the full protocol stack and I have to go into, switch off state. Mobile continues further into that state. So while this is happening, MME He is now first time going and explaining the situation to Enode B, telling Enode B that UE context release, explaining Enode B, hey man, whatever the UE context that you have created so far for this particular, for this mobile user, you are supposed to release that UE context. You have to delete everything. You have to delete the radio bearers, both the signaling radio bearers, data radio bearers, everything you have to delete. You have to delete the S1 tunnels created towards S gateway. You don't know the reason. The reason is mobile is detaching. You don't know it because I'm speaking to the mobile equipment with the NAS messages. I'm speaking because you can't read the NAS messages. You don't know it. But I'm telling you anyway now. Please release everything. UE context release. So it is going to quote S1 AP UEIDs that are applicable for this mobile one last time. MME UEID is this, eNodeB UEID is this. So it quoted the UEIDs, that is one, that is the first IE which is containing both the IDs together, and then the cause is detach. I'm doing this destroying of your context for this user because mobile is detaching from the LTE network. We don't need to maintain that user's context anymore, MME proposed. Meanwhile, whatever the notify request we have sent to HSS has come back. The HSS did not reply back immediately. It took some time because here we are not dependent on the notify answer. It is not related to any particular mobile equipment's purpose. It is just a notification to HSS that mobile equipment is detaching from a service. But it is not compulsory to immediately reply back, or MME is not waiting for this reply to proceed with the further steps. MME proceeded further already. MME told mobile equipment that he has accepted the detach. MME already conveyed to eNodeB that please delete the UE context. Once this is done, so this is all the repeated information, guys. Nothing new will be present in that. That's why I'm ignoring it. Inbound, UE context release, successful outcome. It is telling who eNodeB is conveying this information to eNodeB is conveying it to MME that I have deleted the UE context. I forgot about this user. The user for whom the MME UEID is this, eNodeB UEID is this. For this user, I have deleted the UE context. From now onwards, I want to deal with this user. eNodeB accepted. So radio related things are deleted, S1 related things are deleted, S gateway to P gateway, everything is already deleted. So now we can say that the mobile equipment is in detached state again. So before this log file is started, mobile is in detached state. After the log file is ended again, mobile has come into attached state, again gone back into detached state once again by performing an exclusive detach by on his own. It is performing the detach mechanism as well. And if mobile equipment is in detached state for too much time, a timer that is configured by MME will be expired. What MME will do is MME would send a okay, so there are some device watchdogs because there is no activity going on right now. But after some time, after these device watchdogs are sent, once a timer expired, MME can send a outbound diameter message called as PUG request. So what is the meaning of PUG request? MME is reporting to HSS, mobile equipment is detached for too much time based on a timer that is configured on my side. So I voluntarily discarding all the information I'm maintaining related to this particular mobile from my database. That is what I'm reporting it to you. With this PUG request. Meaning is, if the mobile equipment comes back into the attached state, because this PUG is happening, every time mobile comes back into the attached state, MME need to request for subscriber information once again, because MME is discarding the subscriber data that is stored with respect to this particular mobile from his database. And after deleting that subscriber database, it is reporting to HSS with this PUG request, creating a session ID and explaining which users related details have been discarded. This users related subscription information completely have discarded. You are telling this to HSS. So what does HSS do? If HSS does that, inbound, um, it's a per GUI answer. There is a inbound message per GUI answer. Yeah, HSS is coming back and telling you that's okay, man. Thank you. Nothing much. Result code, diameter, success. All the other information is repetitive. So with this, what is the situation again? We have gone back to square one. Mobile, yet MME is also not having any subscriber information. Not only mobile detached from MME, but MME doesn't have any subscriber information anymore. If mobile try to initiate a attach procedure with the MME once again, MME have to start from authentication, security mode, all those things. After that, by sending an update location request, it receives update location answer. It gets the subscriber information once again from the HSS at the time when the mobile is attaching to the MME freshly. So the procedure we have studied is one attach procedure with the default bearer, attach with the default bearer. So along with the default bearer, mobile performed the attach, and also we have completed the detach as well. We have done both the functionalities. Okay, with that, we have completed one log. So today I will send you this log file to you. Whatever I have explained to you so far. So this same log file as it is, you get it. You have to study this log file and try to understand that things. So again, we have device watchlogs here because when there is no activity going on diameter interface, device watchlogs will keep happening to make sure that the link is not down. So that is these device watchlogs, and we have reached the end of the log file.